All right, pre-calculus in 5, 4, 3. Welcome to another pre-calculus lesson with the live studio audience. All right, and today we're going to do a lesson 9-2, which is about circles. Okay, that's a good worksheet title. Okay, now what I have is a circle. Let's see, I think we actually did this on the last section regarding Emily Rawson. Stephanie Rawson. Let's see, what was it? Horizontal distance. Remember the horizontal distance, vertical distance? Remember those? Do you remember that any point on a curve is called x comma y or x comma equation? Okay, did we do some of that? I think we did some of that, right? So, okay. So x comma y or x comma equation is any point on a curve, all right? So let's just say xy is all these coordinates right here. I'll just call the center hk just for fun. Ooh, that's going to be round for 2. All right, and there's the radius. Now, I can find the distance between those 2 points by using the distance formula. And it starts out with a big old long square root.
Yeah.
Very nice, all right? Now, it's going to be the square root of, what's the first part of the formula?
X.
Okay,
X sub 2.
x2 minus x1, although you can do it the other way, it still works.
Okay.
x2 minus x1 squared. Oh my gosh. All right.
Okay.
Didn't come in 2 minutes ago before we started. All right, so you get x2 minus x1, which is x minus h squared. And it is plus because the distance formula comes from what? Pythagorean theorem. Very nice. D flowers. Very nice. Okay, so it's plus, and then what comes next?
Y2.
y2 minus y1, which would be y minus k squared. Oh, wait a minute. I just did the distance. Oh, the distance from the center to the edge of the circle is its radius. Bingo. And if you wanted to get rid of that big ugly square root right there, we could do what to both sides? What if you square both sides? You would get x minus h squared plus y minus k squared equals radius squared. Oh, wait a minute. That does look familiar. Back in Algebra 2, that is the formula for a circle. Bingo. Very nice. Okay. So what we'll do is we'll have some really easy problems with this. All right. I'll give you a center and a radius, and all you have to do is plug it in and find the equation. That's easy. Piece of cake. All right. Important, but it's one of our things on the list over there. In case Dr. Looney is watching this right now, I have all my standards over there on the board. Turn the camera. They're all over there. So we're going to be talking about circles, ellipses, hyperbolas, all kinds of stuff during this chapter, all right? Now, we're live on camera here. Here, take it. All right, now, okay, what this says is the only x, y's I want in the entire world, the only allowed points are going to be points that are exactly this distance from the center, which would map out a circle. That would map out all those. And would eliminate all the rest of them. Okay, so there we go. Now, and by the way, of course, distance formula, equation of a circle, what theorem? Pythagorean theorem. They're all the same thing, essentially. Okay, matter of fact, the radius is part of a hypotenuse theorem, right? Radius is hypotenuse, radius squared, got it, done. Easy. Here's a super easy one right here. Write the equation of the circle that is pictured here. 3, 4, 7, 4. Okay. Now, remember the 3 ingredients you need to write the equation of the line? You gotta have x, y, and m. A circle also has 3 ingredients. H, K, and R. If you can get H, K, and R, you got a circle. It's that easy. Okay. You probably remember doing this again in Algebra 2. Part of the pre-calculus standard, so we have to go through it. Now, that sound means it's time to look for the center. All right? The center is 3, 4, which is your h and k. And the radius would be the distance from the center to any edge of the circle. That distance, oh, that's what type of distance we did before?
Horizontal.
Horizontal distance, which is 7 minus 3, which is 4. There's your radius right there. Okay? So now you just take those, stuff them in the formula, place them in the formula, and you're done. X minus 3 squared plus y minus 4 squared
Equals 16.
equals 16, which is 4 squared. And that is the equation that would map out only these points and no other points in the universe, just this right here. Okay? All right, so there's that. Easy question. That's a gimme on the next test, right? Is that a gimme?
Gimme.
Okay, and very easy, right? Okay, now, part C, we have a basketball. All right, and in this,
Should we do part B first?
should we what?
Yeah, I think we should.
I think we should do part B.
Part, oh, I just breezed right past it.
Yeah.
I guess it's not important.
No, I was just gonna say, part C is gonna be a basketball, it's gonna be a fun example. Now, in the meantime, let's do part B. Part B is the intersection,
That's a pretty good stuff.
which is,
Is it 3, 4, 1?
okay, so we got this. Now, we need to figure out the intersection between the line and the circle. Something we will also do in calculus, and we'll do some stuff with it next year. So, before we get there, we have to understand this right here. That line intersects the circle at how many places?
2.
2 places. We have to find them both. Well, now, wait a second. We did intersections before. When we try to find the intersection of 2 different curves, we just did what with them, remember? Set them equal to each other. Very good. So if I have 2 graphs and you set them equal, I'll find out where they are equal or intersect. Right? That's easy. All right. So let's set this equal to, wait, no, equation.
But you have a
X
10.
plus Y.
Make your own equation.
Okay.
You have a 10.
How about HK and R, but what's the HK here?
0.
It is centered at the origin. All right? My favorite place to center a circle because it's so easy there. Okay? Perhaps if you are a future engineer, you may have problems where you center it at the origin to make it easier in real life. Okay? Radius.
3x.
You know what? This little hint right here. This is a perfect circle. Okay? I guess it doesn't actually say that. Assume it's a circle. Now, that radius is 10. So you're going to do x minus 0 squared. Do I have to write x minus 0 squared?
Yes.
Okay, wait a minute. I can just write x squared. So it's x squared plus
Y
y squared equals
100.
100. Very good. All right, and there's my circle. Okay, so according to what we've done in the past, if I just take the 2 equations and set them equal to each other, I can get the intersection points, right? Got it. All right, so let's take this line and let's set it equal to, wait a minute, you can't really do that.
Solve the y.
That's the problem right there. That's the fix. Very nice. Well done. Agents, Flowers and Mikowski. All right. Top secret agents.
Oh, we're agents.
Yes, that's right. We're super sleuths. We're math detectives. Okay? You guys are cracking the case here. So, every time I gave you graphs in the past and I said find where they intersect, you always took them and set them equal to 0, but every equation I gave you was solved for y. And this is not. So, first of all, why don't we take this and solve it for y? So let's do y squared. What should we do first?
Sure.
X squared. What should I do next? Take these, oh, wait a minute.
Plus
Oh, take the square root of both sides. One of 2 cases in math where you create a plus or minus, right? Okay? Now, remember before, we did this, we talked about semicircles before, right? Remember that the positive square root
This
is
is
the upper half, and the negative square root, that's the lower half. The question is, should we just toss out one? Do we need them both, or do we just need one semicircle here? Well, it actually intersects both parts of the upper and lower semicircle, so keep the plus or minus. That's good. Okay? All right, now do we have 2 things that y equals?
Yeah.
So that's how the intersection works. If they're both y equals, you can put them together. As a matter of fact, that's a property you may have learned way back when. Geometry, algebra 1 maybe? If A equals B and B equals C, then A equals C by the
Transitive property.
transitive. Whoa, several of you really quick with that one.
Plus
Nice.
tens.
Oh, well, that's like a tie right there. I'm gonna put you guys in the balance beam. Nice. There were several transits. I'm impressed.
I know you did.
There were like 6 or 7 transits. You guys are smart.
Transitive.
No, not at all. No. Okay, hey, look, all those transitives are on the balance beam now. Nice. All right. Now, that's okay. That's good. That's great. Because usually nobody knows it. They have to think about it for a while. Not you guys. Okay. So, guess what? The transitive property doesn't work unless you have A equals B and B equals C, right? So that's why you have to get Y by itself because it's a link. Now you can connect them. So let's take them, set them equal to 2. So this is a separate column if you want to. All right. Let's see. What do we do first to try to solve for X here? What do we get rid of?
Square books.
You know what? Yeah, it's in square root. Let's square both sides and knock that square root out of there. So quantity square both sides. And by the way, when you square a plus or minus, disappears because a plus squared is a positive and a minus squared is a positive, so it's all positive. So that's going to be just a regular 100 minus x squared. And the 3x quantity squared is going to be a what? 9x squared, all right? And then we have to get all the things on one side equal to what? Equal to 0. And I like to keep my x squareds positive, so let's bring this stuff over here. That would give us how many x squareds? 10x squareds minus 100. Okay. You know what the inside of a square root is called, by the way? I don't know if you've done that before in class or not.
Wait, inside of what?
The inside of a radical.
I'll say, but that's,
It's close.